I just remembered that I didn't read the last question when I finished. Didn't I say you should always read the question when you finished, right? As a good math student, you should always read the question at the end to make sure you answered everything. And I didn't do the domain and range because I didn't read it, so I would like lose a whole mark for that if this was a test. And it's going to be on video that I forgot because I already ended the video. It's like, I know. I'm working on it. I'm working on it. So, state the domain and range of each function. The domain of the red one, I'll color code it. You would assume there's arrowheads on the end. So we could say the domain is everything. You could either do it XER, but I'm going to use interval notation this time. The domain goes from negative infinity to infinity. If I was using the interval notation for the range, the smallest y value on the red graph is 0. And it goes up forever. So I would say 0 to infinity. On my blue graph, the domain is still everything. And the range is now from no smallest value, because the arrows go down forever, so start at negative infinity, but it goes up to and includes 0. I think, that question was, we were in between classes, started it last time. That's my excuse why I forgot to read it again. Okay. Oh, and I started the video so that, and I've admitted it to on video, for example, too, that I made the mistake. So you've got video evidence that can do a compilation. I bet you can find lots of videos that I made mistakes on. Okay, second question. We've got the graph of g of x. Sketch the graph of g of 0.5x. So now, the 0.5 is inside the function. So again, last time the numbers were outside of the function. This time it's inside the function. Anytime something happens inside the function, it's going to be horizontal. And now we have to decide, will it take this graph and stretch it horizontally, or will it compress it horizontally? And this will be a horizontal stretch. We'll write it out. Are you okay if I use abbreviations? Okay, so it's a horizontal stretch. What's going to happen? Why is it a stretch? Because remember, if this 0.5 is equal to a half, with horizontal stretches and compressions, we always multiply by the reciprocal. So we take the fraction, we flip it, and multiply it by the reciprocal. Anytime you're multiplying by more than 1, that always stretches something. Anytime you multiply by a fraction less than 1, that's going to make it compressed. So now we know that our x values are going to get multiplied by 2. If we want to show this algebraically, we have 4 key points on this graph. We've got negative 3, 2. We've got 1, 5. Negative 1, 5. We have got 3, 3. And we have 4, negative 2. If we want to show the algebra of how it's changing above the arrow, I can say, what am I going to do? I'm going to multiply all my x coordinates by 2. Now, what you didn't see as I wrote down those numbers is what all happens inside my head, right? Unless I talk it out loud, you don't see what I'm doing inside my head, okay? I can tell you right away that you guys are in grade 12 pre-calculus. you are pretty good at multiplying by 2. Okay? I'm just saying, you are very, and numbers like, 3 times 2, not very hard. Okay? But we have to be really careful, because when we do things that are so easy for us that we almost don't have to think, sometimes we don't think about it, and that's when we make mistakes. Okay? I have seen students who start off perfectly, and they have -6, 2. And the next one, they write -2, 10. What happened? They multiplied the y by 2. Just because it's so easy they weren't thinking, they just do something extra on that, right? So I'm going to tell you that in pre-calculus, even when the things are easy, especially when they're easy, once you're done them, tell your brain, do a quick check. Did you do it right? Yeah. Multiplied by 2? Yep. Yep. So each one that I did a quick check. You didn't see because it just looked like I wrote the answers. But I'm always doing a quick check to see, did I do that right? Did I do that right? And yes, that'll take a few milliseconds more for you, checking it as you go. But it will save you a ton of time, because how many of you have done a math question, check the answer at the back of the book to find out it's wrong, and then look at your question for 2 minutes, where did I make a mistake? And finally that was a dumb mistake. And that was a lot of time that you spent. So you can save yourself time if you're doing quick checks along the way. There's one place I could do a quick check. Another place that you could do a quick check is after when you graph it. So now I'm going to plot these points, -6, 2, -2, 5, 6, 3, and 8, -2. Visually, the way that a stretch works, this is a horizontal stretch, is you stretch it away from the y-axis. So it would be like, as a visual, I grab half the graph on this side, half the graph on this side, and pull it away from the y-axis. Does my final graph match that? And sometimes when you draw your final graph, everything seems to match, and then but you would have why do I have a point way up there? That's also giving you a hint. Maybe you made a little mistake with that point. If it doesn't match the idea of this graph as being stretched out, it might be giving you a hint that you made a mental math error somewhere. And that would be the one that I would check. I learned from my mistake last time. Read the question again. It says domain and range of each function. So again, I'll color code it. The domain, and this time I'll use set notation. The smallest x value is -3. The largest x value is 4. The range of the red one, the smallest y value is -2. The largest y value is 5. For our blue graph, the domain, the smallest x value is -6. The largest x value is 8. And for the range, the smallest y value is -2. And the largest y value is 5. Observations. Notice the range doesn't change between the red and the blue graph. Why? Well, algebraically, what's the only thing we did change? We only changed x values. So it should make sense. The y values didn't change. Can you see the x by 2 showing up in the domain? Right? It started -3, now it's -6. It ended at 4, now it ends at 8. So we can see some of the same patterns show up in different places. So I'll get you to write down questions 4 and 8 and circle them.